Good day guys, welcome to my channel. In this video I'm going to be demonstrating how to add load to your 2D frame in the RKANALYSIS. In our previous video I demonstrated how to define the node, to add the element, and to define the node constraint or support. To illustrate how to add load to your model in RKANALYSIS, I'm going to be using this example. This is 2D frame. I'm going to be using this load example. On element 1, we do have a point load and a point moment applied at distance 2 meters from the start node. As noted, the load in RKANALYSIS you input the load in RKANALYSIS based on a local coordinate system. This is a coordinate system for element 1. This is a local coordinate system for element 1, local coordinate system for element 2, and local coordinate system for element 3. And the joint load I applied at global coordinate. This is a global coordinate for the structure or for our model. This is a global coordinate. These are the local coordinates for each member. So let's go back to our window. To add load on a window, we also have two options. The first one is to click on the toolbar button, add load, and the second option is to go into the input menu, choose load. Either one, if you press one, this will show this dialog box. On the dialog box, you will find three tabs: one for the point load, another one for the uniform load, and the third one for the joint load. Let's start with the point load. As per our example, we have a point load of 50 with the magnitude of 50 kg, a kilonewtons. As you can see, it shows -50. It means that is opposite to the y direction at local coordinate. Opposite the y direction at local coordinate. That's why it shows -50. And we got the point moment, which is -30. This is in the opposite, is a clockwise. Clockwise is negative and anti-clockwise is positive. And this is the angle of the load as per our dialog box. We do have a -50. Let's put -50, and the point moment is a -30, and the position is at 2 meters from the start node, which is this distance A is 2 meters, and the angle is the angle between the angle of the point load relative to the center line of the element. This is the center line of the element. This is the angle that we need to be define. The angle for this particular case is 90 degrees because the load is at the right angle with the center line of the element. And we also need to choose the type of load. Is it dead load, point load, live load, snow, or wind load? So the particular case I'm going to choose live load, and also a default load type. And if you click on add button, you need to select the also instruction here, select the element or select the member. So this is our load. We have the point load at the point load and the point load and the point moment. And let's add the uniform load. Let's go back to our sketch. It's the uniform load is about 20 kilonewton per per meter. We didn't add, let's assume the distance is 1 meter. I want this distance. This distance, we would take it as 1 meter. So the distance as 1 meter, and then you can define it from here. X1, this is X1, and X2. X1, let's take it at 1 meter. The value is minus 20. W2 is minus 20, and the angle is the same as the previous, is the angle with the load, which is we take as 90 degree. And this distance is 1 meter, and X2 is, take it as 3 meter. If you wanted to apply on the full length, you can just click this button and the load will apply on the full length. Or if you don't want it, you can just put your measurement 3, and the load type I will leave it as live load. Let's click on the button on the load. It's done. You have added your uniform load. Let's add the point load on as per our drawing. In the sketch we do have minus 50 kilonewton on the y-axis and minus 60 kilonewton on the x-axis, and we do have a 20 kilonewton per meter, and let's define. We got minus 50. No, this is minus 60 minus 50, and this is 25. Is positive, right? This 25. Okay. And you can also choose what type of load. I will leave it live load. Minus 50 and minus 60. That's good. 60. Okay. If I click, it will ask me to select the node. There we do have our load applied. Everything is done now. Let's close our window. So there we're done with the load input, and we're ready now to analyze. You can view this load to make sure it's being done. The input is being set correctly. We can go to view, now edit, load table. If you click on load table, you will see all your load here. Element 1, we got load type concentrated load. The element 1, the magnitude is minus 50, the position 2 meter, angle 90 degree. This is the point moment, minus 30, which is exactly what we applied. And then the UDL, this is trapezoid UDL, this is uniform distributed load, and the X1 is 1 meter, and the magnitude is minus 20. X2 is the magnitude is the 20 kilonewton per meter, and the angle is 90 degrees. So you can also change it from here. You can change the, let's say for instance, I can change this value to 30 kilonewton by clicking edit. The value will change from here, and there you go. And now we're ready for analysis, because you can't anyway, it's fine for now. We are going to stop on the load input. We are going to look at the next step. On the next video, we are going to look at how to do your load combinations. Thank you for watching, guys. See you on the next video.